Hello everyone, welcome to the lecture. Myself Devananda Rao, working as Associate Professor in the Department of CSC, MLR Institute of Technology, Hyderabad. Today's topic is Non-Deterministic Finite State Automata, in short NFA or NFSA. As we have discussed in previous class about DFSA, that is a Deterministic Finite State Automata. In DFSA or DFA, upon being a particular state and reading an input symbol, the subsequent state is uniquely determined. That means, for a particular state and for a particular input symbol, we can define next state uniquely. For example, in Q0 is the initial state. For a particular state Q0, if you read a particular symbol input, we can define next state uniquely. That means, in DFA, for a particular input symbol, for a one input symbol, only one transition occurs, unlike this. This is not happen. In DFA, for Q0, for input symbol A, there should not be more than one transition. That is, the next state should be uniquely defined, like this. From Q0 to Q1, there is a transition for input A. Each transition in a DFA is deterministic, leading to a singular next state. That means, deterministic means uniquely defined next state. From a particular state for a particular input symbol, next state is uniquely determined. That is singular next state. Coming to NFSA, that is non-deterministic finite state automata. NFA contrasts to DFA by allowing multiple potential transitions upon encountering an input symbol. See, in Q0, for input symbol A, we have more than one transition. More than one transition. From Q0 for input symbol A, we can go to Q. We have choice. We have two choices. That is, I can go to self state Q0 to Q0 for input A, or I can go to Q1. So, NFA allowing multiple transitions upon encountering an input symbol. That is the main difference between NFA and DFA. In NFA, machine has liberty to move one of several states from a particular state after reading an input symbol. See, from Q0, after reading symbol A for input symbol A, we have liberty to move either to Q1 or to Q0. NFSA state diagram scenario. In this given scenario, the given machine is in state Q0. This is state Q0. The machine is in initial state is Q0 and reads input symbol A like this. It offers a choice between transitions to Q0 or Q1, illustrating the non-deterministic aspect. See, from Q0, we have two transitions for input symbol A. One is from Q0 to Q1, Q0 to Q1, Q0 to Q1, another is Q0 to Q0. Next, if the machine is in Q1, it reads B, it has the choice of going to Q1 or Q2, hence the machine is non-deterministic. So, in Q1 for input symbol B, I can go to Q1 or I can go to Q2, we have choice. So, in this particular machine, the scenario, this diagram, transition diagram will accept language, that is A power n, B power m, such that n comma m is greater than or equals to 1. So, that is number of A's, n number of A's followed by m number of B's, like. So, these are the valid strings. This is the NFA for the language A power n, B power m, n comma n is greater than or equals to 1. See, you see for this language A power n, Q0 is the initial state. For input symbol, I will take input symbol A, B, B. A, B, B. Initial state is Q0. This is string processing. Q0, first symbol A. We have two choices. From Q0, for input symbol A, we have two choices. One is I can go to Q0 or I can go to Q1. So, I can go to Q0 or I can go to Q1 for input symbol A. Next input symbol is A. So, Q0, we have two choices. Either I can go to Q0 or I can go to Q1. I can go to Q0 or I can go to Q1 for input symbol A. From Q1, there is no transition for A. See, from Q1, there is no transition for A. So, that there is no transition. Once again, third symbol A. Q0 for A, I can go to Q0 or I can go to Q1. From Q1 also, there is no transition for A. Here for Q1 also, here there is no transition for A. So, first three symbols we have seen. Next is B. From Q0, there is no transition for B. From Q0, there is no transition for B. From Q1, there is a transition. So, Q1 for input symbol B, from Q1 for input symbol B, I can go to Q1 or I can go to Q2. I can go to Q1 or I can go to Q2 for input symbol B. I will write here input symbol B. Then from Q1, next last input symbol B, from Q1 there is two choices, either I can go to Q1 or I can go to Q2, Q1 or Q2. From Q2 there is no transition for B. So, A, B, 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 this is the scenario. We have multiple paths from Q0. So, one is from Q0 to Q1. So, the path is ended here. Another path Q0, 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 Q1. Another path is Q0, 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 Q1, Q2. Another path is Q0, 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 Q1. So, there are multiple paths from initial states, but there is only one path that takes you from initial state to final state after reading the string A, B, B, B. So, after reading string A, triple A followed by double B, that is A power 3, B power 2. That is, in general, that is A power n, B power m, such that n comma m is greater than or equals to 1. So, after reading these 3 A's followed by 2 B's, there is one path that will take you from initial state to final state. Q2 is the final state. This is the final state. This is the initial state. The path is this Q0 to Q0, Q0 to Q0, then Q0 to Q1, then Q1 to Q1, then Q1 to Q2. That is Q0 to Q0 for input symbol A. Next Q0 to Q0 for input symbol A. From Q0 to Q1 for input symbol A. Then Q1 to Q1 for input symbol B. Q1 to Q2 for input symbol B. So, 3 A's followed by 2 B's. This is the sequence of states, that is Q0, Q1, Q0, 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 Q1, Q1, Q2. This is the required sequence of states, that is the path taking you from initial state to final state for input symbol A, B, B. So, this is the NFA state diagram scenario. Next, the formal definition of non-deterministic finite automata is defined as 5 tuple, that is M, NFA is M, that is Q, sigma, delta, Q0 and F, 5 tuple, where Q is finite set of states like Q0, Q1, Q2 and so on. Sigma is input alphabet, that is binary alphabet 0, 1 or any digits, set of digits, any input alphabet. Next, Q0 is the initial state of the NFA, F is the set of final states, delta is a transition function, Q cross sigma to 2 power Q. This is the only difference between NFA and DFA, remaining tuples are same. This is NFA transition function, DFA transition function is Q cross sigma to Q only. That means from a state for a particular input symbol, we uniquely define the next state. Here from a state for a particular input symbol, we may have more than one outgoing state, next state. Here in DFA, next state is uniquely defined. Here in NFA, we cannot define next state uniquely. That means more than one state may occur. In this is an example for NFA. The language of the following NFA consists of all strings over 0, 1 whose third symbol from the right is 0. This is the NFA diagram for strings consisting the symbols zeros and ones, but the third symbol from the right hand is 0. So, we have string last symbol right hand. So, this is right hand. The last symbol is either 0 or 1. From right hand, last symbol is 0 or 1. From right hand, last but one is 0 or 1. Last but one is 0 or 1. But third symbol from the right hand, that must be 0. So, fourth onwards towards left side, anything, fourth bit either 0 or 1, fifth bit either 0 or 1, either 0 or 1, so on. And also the length of the string is also not given. Only the mentioned constraint is the third symbol from the right is 0. For that we need to draw the transition. Here this is the NFA diagram for the strings having third symbol from the right hand is 0. See, the last Q3 is the final state. Q3 is the final state. From Q2 to Q3, that means last symbol, that is either 0 or 1, either 0 or 1. Q1 to Q2, that is second symbol, that is from the right hand, 0 or 1. Q0 to Q1, that is the third symbol from the right hand, that must be 0. After that, fourth symbol onwards from the right side to left side, fourth symbol onwards, it may be either 0 or it may be either 1. Okay, I will rewrite here. Q0 is the initial state. Initially, you can read any number of zeros or any number of ones, as many number of zeros, as many number of ones, but third symbol from the right hand is 0, Q1. So, second symbol from the right hand is either 0 or 1. First symbol from the right hand is either 0 or 1. So, I can go to final state. But here Q0 is the initial state, has multiple transitions on 0 and Q3 has no transitions on both 0 and 1. So, you have to identify this point. From Q0, for input symbol 0, we have two transitions, choice of two transitions. One choice is one going to Q0 to Q0, another choice is going to from Q0 to Q1. Coming to Q3, there is no transition defined on 0 or 1. For 0 or 1, there is no transition. NFA will allows need not to define the transition function for every symbol, input symbol for a particular state. But in DFA, for a particular state, for every state, we need to define the transition function for all the input symbols. Another example of NFA. NFA accepts strings beginning with 0. So, the input alphabet is 0, 1, but the first symbol in the string is 0. Second symbol onwards either 0 or 1, third symbol 0 or 1, fourth symbol 0 or 1. The length is not given, but the only constraint is the first symbol is 0. Here Q0 is the initial state. If read 0, I can go to final state Q2. There I can read any number of zeros and 1. So, that means second symbol either 0 or 1, third symbol either 0 or 1, fourth symbol either 0 or 1 and so on. Only first symbol is should be 0. Note Q0 has no transition on 1. Q0, there is no transition defined on Q0. No transitions from Q0 on 1. That means no transition from Q0 on Q1. That's why NFA is non-deterministic. it is acceptable for the transition function to be undefined on some input elements for some state. For a particular state, for some state, it is acceptable for the transition function to be undefined. That means no need to define sometimes for a particular input symbol. Thank you.